Good morning, good afternoon, good evening. Welcome to this instance of the Antrea community meeting. For today, we have a presentation from Wenning. I don't know exactly what the topic is, but it has to do with Windows 2022. So, Wenning, please go ahead.
Sure. Thanks, Salvatore. Let me share my screen. Thanks everybody. Today my topic is use Windows HPC to build Antrea agent image. The motivation is that the Windows Node shall upgrade its operating system version from Server 2019 to Server 2022 in production setup. This is because that Windows Server 2019 has reached its end date of the mainstream support since January the 9th, 2024. So in both production and in user setup, we may need to think about supporting Windows Server 2022 as the major operating system. But for Antrea, the existing Antrea agent image was bound to Server 2019. It means that, firstly, our Antrea agent image was built based on Nano Server 1809, which was compatible with Server 2019. So if we run this agent image on Server 2022, it may hit some unexpected issues in the future. And in this case, we need to think about the bump up agent image. And another reason is that for Windows, especially for us, we are using Hyper-V isolated containers. It requires that the operating system version used in the container image must be consistent with the hypervisor. So to bump up Antrea agents from the version 2019 to Server 2022, we have two options. The first option is that we can continue using Hyper-V isolated container and modify the agent image base using the Nano Server 2022. But it may mean that if we use this solution, we may not use Antrea agent's image to be compatible with Server 2019 in the future anymore. And the second option is that we can switch our Windows-based image to HPC. And then what is HPC? HPC means host process container-based image. It is provided by Microsoft, and it is a minimal-based image. The image link I have pasted in this slide, and this base image was used with host process containers only. It means that with a container using HPC, it can operate as normal processes, and it has access to the host network namespace and host storage and host devices when given the appropriate privileges to the users, which were used when running the processes inside containers. So if we switch to HPC, some benefits include, firstly, the image size is very small. The base image is only a few KB. I have tried to put the image on my local setup. In the Docker registry, I can see that the image was only about 7.45 KB. And the second benefit is that the image allows for a single container image to be used on any Windows Server version. For example, if we build an Antrea agent image using the HPC, it means that our Antrea agent image can be run on both Windows Server 2019 and 2022. That is because the containers built on the HPC base do not inherit the same compatibility requirements as the Windows Server containers. As the HPC-based image is very small, there's no inherited Windows system files like the directories for Windows System 32, and it doesn't provide such files to limit the usabilities. So, but it also means that when we run a container, run processes using a container based on HPC, it will leverage the host Windows, the Windows host file system and network to provide the functionalities. In the meanwhile, there are some limitations for the HPC. First is that it required containerd runtime with Windows 6.18, and containerd 1.7 is recommended. And the second limitation is that both named pipe mounts and unit domain sockets should be accessed with the host path, but we cannot use the host process container relative path in the containers. So back to the comparison with the two options of the solutions. If we use the Hyper-V isolated image, it means that we must use the image base with nano server and plus some versions. So for example, for 2019, we may use nano server 1809, but when we come to server 2022, we need to modify the tag of nano server to LTSC 2022. And in the future, if we bump agent image to support server like Windows Server 2025, we still need to update the base image. And the secondly, for Hyper-V isolated image is that it can support run the container image with multiple types of containers, including host process like what Antrea agent is running in the Kubernetes cluster, and it can also support Hyper-V isolated image. For example, we can run Docker run Antrea agents, then Antrea agent processes and Antrea OS processes can be run on the Windows host without any additional requirements. And the second feature for Hyper-V isolated is that it has compatibility. It is required compatible with the Hyper-V version. And the fourth feature is that it provides a larger size of the image. That is because the file system provided by the base image. But for HPC-based image, it means that the agent image base is using HPC, then Antrea agents on Windows can only be run with the host process containers. And currently, the HPC image cannot be built with Docker desktop. Instead, we must use Docker build kit or other tools to build the images. That is some requirements for the build. And the fourth is OS compatibility. It is an advantage for the HPC-based image. It means that Antrea agents can be used on any Windows Server versions. So in future, we don't need to think about bump up the agent base when we upgrade the Windows Node operating system versions. And the last feature is the smaller size. The base image only takes several KB, so the total size of the agent image may reduce several hundred megabytes. And so our solution is the option 2. So we finally choose to use HPC as the base image. So if we following this option, the changes include firstly about the build environment. We must use Docker BuildX, the cross-platform capability to build a Windows image. It includes that when we build the Windows image, we must provide a flag platform, Windows MD 64. And to support building the images, there are two output options. One is to save the final image locally. Then we need to provide the option provide the flag type equals Docker and the dest needs to provide the local tar file name. And if we want to push the final image to remote registry like Antrea Windows images in our remote registry, we must provide a flag type equals registry. Then after run the docker buildx command, the final image was pushed automatically. And the second thing about build environment is that we can support using Linux VM to provide the build environments. For Antrea, we will use Linux-based. We will use Ubuntu 22.04 by now to provide the basic build environment, including the utilities like Git, make, wget, zip, or some utilities. So in that case, we don't need to maintain Windows-based image anymore. We can directly use the Linux and leverage the Linux utilities to provide the basic capabilities. And we are using Golang on Linux VMs to build Windows binaries by across the operating system in the middle layer. And the second change is for the Docker file. In the Windows agent image and the Windows OS image, we will use HPC-based image to store the final binaries. And we have removed Windows-based image in our repos. The third change is about OS dependency installations. For our previously agent image, we are trying to download OpenSSL files and extract the zip file. Then we place the DLL files to the image system path. But because we're switching to HPC container image, there is no system path inside the container image. So the alternative is that we copy the DLL files to OS binary path directly, including the OS OpenVSwitch user bin and OpenVSwitch user as bin. And for the second changes in the OS dependency installation is we copy the vSeries distributable file binary into the container image and install it on the Windows host in the Antrea agent init container stage. The reason is similar to the OpenSSL DLLs because we cannot run the exe files in the image build stages. So we have to copy the file and install it finally when we run the container images, run the containers on the Windows node. And the fourth major changes is about the CI. We have built Windows images on the Linux image builder VMs for Windows Jenkins jobs. So this is different from the previous CI jobs. In previously, we have a separate Windows image builder VM, but because we have to use Docker buildx on Linux VM, so we can not we don't need the Windows image VMs anymore in the future after the HPC. And for CI, for the GitHub actions, there are some build action. So in these actions, we switch the Windows Server image to Ubuntu latest as the VM base. And the third part, the last part for CI is that so we have provided a script to push OS Windows image automatically when it's updated. Finally, I have provided the link for the change. By now, the change is already merged in the TOT of our Antrea repo. Then what is about the impact for this solution? Firstly, is about the image size. After we switch to HPC based, if we save the final image locally. The tar file is about 90 megabytes. But for previously, if we use Windows Nano Server with version 2019, the local file is about if my memory is correct, it should be 200 over 200 megabytes. And for Docker registry, the image size was reduced to 236 megabytes using HPC. But for the previously Antrea agent image in the Docker registry is about 700 megabytes. So we reduced the image size much. Then another impact is about the build time. This build time was observed from my test. When we build a Windows OS image, the total time is about 30 seconds, including build the image and push the image to remote registry. And for Antrea Windows, the total time is about 232 seconds at most. Then come to the follow-up. After the test, the change was merged, we still have some work to follow up. Firstly is about the CI modification. It includes we need to upgrade the Windows node in our CI test beds with Server 2022. And finally, we will remove Windows Image Builder VMs from the Windows CI test beds after all Windows Nano Server-based image is not maintained in any releases. And another thing is about OS installation enhancement, because we are now installing the V0 distributables and in the init containers. So we may need to check V0 distributable upgrade cases. And so we have another change here. The enhancements includes check and install V0 distributed files and upgrade OS ext driver in the change. That is all my content. Thanks. Any questions?
Not for me. It was all very, very clear. Do we have any question or comment for Wenning? All right. It seems that we don't have any question for today. Is that correct? Are you sure this is your last chance for asking a question regarding Windows Server 22 support? All right.
It's not
yeah, go
I
ahead.
don't have a question, but I just wanted to say that I think this is a great improvement to the Windows build infrastructure and support. It makes it much more aligned with how we build images on Linux as well, and how we maintain the base images. And so I think this was a great simplification, and decoupling the version with the Windows Server version is also a great addition. So thank you, Wenying.
Thank you.
Okay. All right. Thanks, Wenning. That's actually good and necessary because 2019 is not supported anymore. It's end of life. Okay, good. Do we have any other thing that you would like to discuss for today? Any other topic from the rest of the team? I'll wait as usual a few seconds. All right, it seems that that's all for today. So thanks again, Wenning, for your presentation, and thanks to the whole team for joining today's meeting, and we will meet again in 2 weeks' time. Have a great evening or a great afternoon, and talk to you for the next meeting.
Thanks.
Thank you. Bye-bye.
Bye.